Welcome back to G Fun Facts Online, your go-to spot for amazing science discoveries. Today, we're diving deep, literally, into one of the most exciting frontiers in the search for life beyond Earth, the icy ocean worlds of our outer solar system. Imagine moons, orbiting giant planets like Jupiter and Saturn that look like solid balls of ice from the outside. But beneath those frozen shells, scientists believe there are vast, hidden oceans of liquid water. We call these ocean worlds, and two of the most famous are Jupiter's moon Europa and Saturn's moon Enceladus. These aren't just small ponds. We're talking about potentially global oceans, some possibly containing more water than all of Earth's oceans combined. So why all the excitement about these distant, frigid moons? Well, it turns out they might just have all the key ingredients for life as we know it. First, there's liquid water, a fundamental requirement. Second, they likely have essential chemical elements. Think about it. These oceans are probably in direct contact with rocky cores or mantles. This means water-rock interactions could be happening, a process that can release minerals and create chemical energy, both vital for life. There's even evidence pointing to ongoing geological activity, perhaps hydrothermal vents on their seafloors. On Earth, hydrothermal vents are like oases for life in the deep, dark ocean, spewing out chemicals that microbes can feed on. Could similar environments exist on Europa or Enceladus? Now, you might be wondering, how on Earth, or rather off Earth, do we study oceans that are buried under kilometers of ice? This is where things get really cool. Some of these moons, particularly Enceladus, have a spectacular feature: plumes. These are jets of ice grains and water vapor that erupt from cracks in their icy shells, shooting material from the subsurface ocean out into space. It's like getting a free sample. NASA's Cassini spacecraft, during its mission at Saturn, actually flew through Enceladus plumes. And what did it find? Water, salts, and organic molecules, some of the basic building blocks of life. This was a game changer, offering direct evidence of what's in that hidden ocean. Building on this, future missions like NASA's Europa Clipper are being equipped with even more sophisticated instruments. Scientists are developing advanced mass spectrometers and other tools that can analyze single ice grains from these plumes. The goal is to detect biosignatures, substances or patterns that could indicate past or present life. This could be specific types of organic compounds, their ratios, weird isotopic signatures, or maybe, just maybe, even intact microbial cells caught in the ice. But finding water and organics isn't the whole story. To assess if an ocean world is truly habitable, researchers need to understand the conditions within its ocean. They create detailed geochemical models to estimate things like pH, salinity, and the availability of crucial dissolved chemicals. For example, phosphorus is another element vital for life as we know it, used in DNA and cell membranes. Recent modeling suggests Enceladus Ocean could actually be relatively rich in dissolved phosphorus, which is very promising. Scientists also study places on Earth that mimic these extreme environments, like our polar regions or deep-sea vents, to learn how life adapts and what biosignatures might look like in icy conditions. The composition of these plumes gives us incredible clues. When scientists detected molecular hydrogen in Enceladus plumes, it was a big deal. Molecular hydrogen can be produced by hydrothermal processes, similar to those on Earth's ocean floor. This suggests that Enceladus might have chemical energy sources readily available, potentially fueling any life that might exist there, completely independent of sunlight. Of course, there are still many questions. How directly are these plumes connected to the deep ocean below? Are they sampling the average ocean, or just a specific pocket? And what geophysical and geochemical processes have sustained these environments over billions of years? Understanding these details is crucial to figure out if these moons offer stable, long-term, habitable conditions. The ongoing exploration of ocean worlds, driven by these incredible plume analysis techniques and increasingly sophisticated habitability modeling, is a huge leap forward in our quest to find life beyond Earth. By studying and comparing different ocean worlds in our solar system, and eventually perhaps those orbiting other stars, scientists hope to uncover the common principles that govern habitability. Is Earth a cosmic fluke? Or are the conditions for life widespread throughout the universe? These icy moons might just hold the answers. That's all for this episode of Fun Facts Online. Thanks for tuning in, and join us next time for more fascinating facts from the world of science.